For this project, we're going to be creating a script that brute forces a word, a password, or any sort of text in Python. So for example, pretend we are searching for the password lol1. If we run this script, it's going to go through every single combination until it finds that, and it's going to crack it. So, I mean, theoretically, of course, if you were looking for something random, you wouldn't know what it is. But just like with a bike and a combination lock, you would flip through every single number until you find one that actually works. So that's exactly what we're doing here. And we also have a mechanism that goes through common words, so that if we want to make this faster, we will try to go through the common words first, and we might be able to guess it instantly. So this is one of the more cool projects you can create in Python, although I highly advise you don't use this anywhere on the internet, because one, it's very simple and a lot of websites have very strong safety mechanisms against this, and two, it's highly illegal to try to crack any passwords that don't belong to you. So this is for educational purposes only. But to get started, create a new empty project in PyCharm, and I'm going to increase the font size just a bit. And the first thing we will do is create a text file, and we're just going to call this file words.txt. And inside here, insert some words that are commonly guessed. If you make a quick search on Google and you say the top 10,000 most common words, there will be a result on GitHub. I recommend you copy that. Otherwise, in my GitHub repository, which you can find in the resource section of this course, will contain 10 words for you to play around with, or actually 9 words. So if we copy and paste that inside, each one should be on a new line, because we're going to loop through all of these common words before doing the brute force. But once you have a text file with words, and I mean at this point you can even type these out, there's only 9 of them, but as soon as you have these words or other words in your words.txt file, make your way over to main, because then we will start coding. So the first thing we need to do is import itertools. Then we also want to import string and import time. And itertools is an inbuilt module that helps us with iterables and looping through them and performing very efficient operations with them. But the first function we want to create is the common guess function, because we want to check our file for common words before brute forcing. So here we'll type in word of type string, and that's the word we are looking for. And it's going to return to us either string or none, because there might be no results. So with open, and here we need to insert our text file, so words.txt in read mode as words, we're going to do the following. So word underscore list of type list of string is going to equal words dot read, and we want to call split lines, because it's going to read every line and it's going to split them into a list. But as soon as we have that word list, we can check for I match in enumerate the word list, and we're going to set the start of enumerate to 1. Then we can check if match is equal to word, we can return f common match, and we will insert our match. And we will also tell the user which number it was. So here we can type in I, and it will tell us which position the word we just guessed was located in our text file. So of course, the next logical step is to actually test it. So here we can type in common guess, and if we type in caret, because we're searching for caret, for example, and we run this script, nothing's going to happen because we should print this, of course. So if we print that, it should say common match is going to be caret, and that's number 9 in our list. So that's working perfectly. And if we have something that's not there, such as ABC, it's going to return none because we had no matches. So the first functionality from our program is done. Now we can move on to the brute force. So here we'll type in brute force, and it's going to take a word of type string, a length of type integer, whether it contains digits is going to be of type Boolean, and that's going to be set initially to false, and whether it contains symbols, which should also be of type Boolean, which will be set to false initially. And that's going to return to us either a string or none. Now first we need to decide on which characters we want to use for our brute force. So here we're going to use characters of type string, and we're going to call string.ashi lowercase. So we're going to use lowercase characters in our guessing. And if the user wants digits, we're going to, of course, append to the characters plus equal string.digits. And if the user wants to guess a password with symbols as well, we need to add that flag. So if symbols characters plus equals string.punctuation. So that's going to increase the complexity. And the reason we don't use all of this immediately is because the more characters we have, the slower our program's going to be, since it has to loop through all of these characters when it's trying to check. So if you have only lowercase characters, it's not going to take much time because there's going to be around 26 characters or letters in the alphabet, which means we only have to loop through 25 letters in theory. But if we add digits, that's another 10 characters. And if we add punctuation, another who knows how many characters. And this is not even including uppercase characters. So you need to use these wisely, depending on which word you're trying to guess. And that's why a lot of websites recommend you use an uppercase character, digits, and punctuation, because it just makes the password nearly impossible to guess. But right below that, we're going to type in attempts of type integer, and that's equal to 0. Now for guess in itatools.product, we're going to insert the characters, and then we need to specify a repeat length. So repeat is going to be set to length. Then we can type in attempts plus equals 1. So we can keep track of how many attempts we actually went through. And the guess is going to be the string of empty space dot join the list of guess. So what itatools product does is, for example, if you have ABC as the characters you are guessing from, it's going to make every single combination imaginable with those characters. So it's going to try AAA, and then AAB, and then AAC, and so on. It's going to make all of these combinations all the way to CCC. So we're going to go through every single combination using the product. And the reason we need to use .join is because what itatools returns to us is actually a list of combinations. So we're not going to get ABC written as ABC. We're going to get this written as a list of A, B, and C, all separated. But we don't want that. We want the combinations together. So that's why we are joining it. Anyways, if the guess is equal to the word that we are looking for, we're going to return quotation marks, word was cracked in, and we're going to place the attempts, followed by a formatting trick, which is a colon and a comma. So that's going to add some separators to big numbers to make it easier to read in the console. And we're going to say guesses at the end. And for debugging, you might want to print the guess and the attempts because it looks really cool and people think you're kind of hacking or something. But the reason you shouldn't use print when you're actually performing this is because this actually takes a lot of resources, which means if you print once, of course it takes 0.001 seconds, for example. But if you have to print a billion times, 0.001 seconds becomes quite a massive number. So once you're done testing, just comment that out because it takes too many resources. We'll leave it in there for now, and I'll show you later how much time we save when we remove that. But now let's actually create our main function. So def main, and inside here we can say print searching, and we're going to pretend that the word we're searching for is equal to ABC1, so a simple password just to get started. And we want to measure how long it takes, so we're going to get the start time of type float, which is going to equal time.performance counter. And that will give us the current time, and we will compare this to another time later to get the difference. Now it's time we actually perform the operation of searching. So we're going to use some funky syntax. We're going to check if the common match, and we're going to use a walrus operator. And I'll show you what that does in just a moment, but with that, we can also assign common guess to it. So common guess of the password. If we do that, we're going to print common match. So the first thing that's going to happen is that this is going to run and it's going to return something. And right now we know that it returns either a string or none. But regardless of what it returns, it's going to assign it to common match before we run the if statement, which means if this is none, this will not execute. But if this has some value, it's going to execute. So that's just a neat trick you can use in Python with the walrus operator. Else, if cracked, walrus operator again is equal to brute force, and here we need to insert the word we're searching for and the length of the word. So the length of the word in this case will be 4 characters. We're going to set digits to true because there is a digit in there, and symbols are going to be set to true. So if we find something in there, it's going to return to us the password, of course, and that means that we can print the result. Else, we're going to print that there was no match, ellipses. But below that, just like with the start time, we need to get the end time. So we will just copy and paste that below and change this to end time. Then we can print the result. We can print the rounded result of end time minus start time, and we're going to round that to 2 decimals and say seconds at the end. So this will tell us how much time it took. Then if all goes well, we can do our if name is equal to main check and run main. And for this very easy example, we're just looking for a password named ABC1. So if we tap on run, we have a syntax error because I forgot to add a colon at the end of this expression. So once we add that there, we can run this again, and it's going to guess ABC1 in less than 5,000 guesses. And that was pretty easy because it was short and it was at the beginning of the brute force. But the second you change this to a letter such as X, it's going to take a bit longer because it's more towards the end. And right now, for some reason, we decided to do it with symbols, and that should be set to false because there are no symbols. So if we do it without symbols, it's going to try it all again. And eventually, after a million guesses, it was able to brute force into XBC1. But as you noticed there, as soon as we included symbols, it took significantly longer because it has to loop through all the opportunities or all the possibilities with symbols included. And that's why if we set digits to false and we look for a password that does not contain digits, it's going to be significantly faster. It just has to make less computations, which results in less resources being used. But if we have something such as Apple, it's not going to take any time because that's part of our common words. So it's probably worth it to populate this with 10,000 of the most common words you know, because this should be the first priority before moving on to brute forcing. Also, another thing is that we have a fixed length here. And if we have, let's say, some sort of text that says AAA, we're not going to be able to find that text because we told the program to only look for 4 in length. So we're going to have to manually change that to 5 if we want to find a word with 5 characters in length. So if we run that now, it was cracked in 1 guess. I guess that was the first guess, but it was able to find it. So something you would want to do to fix this would be to add another for loop. So for example, for I in range, let's say 4 or actually 3 to 6. So we're going to look for passwords that range from 3 characters in length to 5 characters in length. And with that, we can insert this in the for loop. And instead of checking for the length of 4, we can check for the length of I. So we're going to do this many times. So we don't have to always know the length of the password. And I'm going to change that to BBBB just to show you what's going to happen. So if we run this now, it's going to go through 4 characters, then it's going to go through 5 characters. So that gave us a bit more leeway. But the more characters you loop through, the harder or the more resources it's going to take. So after 7 or 8, you're going to need a really intense computer to do this fast enough. But otherwise, if you remove the print statement, for example, you'll see that instead of 2.48 seconds, we'll get something almost immediately. And there was no match for the 3-letter combinations, the 4-letter combinations, but for the 5-letter combinations, it was immediate. And as you could see, there was a small bug there with this range, and that is because it continued searching for the password because we did not break here. So that's something you can work on in your own time. I'm going to remove the for loop and the break because this is supposed to be simple. So specify your length, which is 5, and we're just going to loop through that. The source code for this entire project can be found in the resource section, so you can play around with what I have there, but that was the main concept behind using brute force in Python.